Welcome back. Last section we looked at the digital modes section, which was a section about digital modes. And today we're going to be more broadening our exploration of modes, and today we're looking at the multi-mode radio excitement section in the Gordon-West manual. So let's start off this section by talking about what multi-mode radio means. When we say that, what do we mean by that? Well, in ham radio you have many different modes of communication. For example, if you want to talk to someone on ham radio, you could use the Morse code mode, which is this mode, which we'll talk about in a second, or you could use a voice mode through AM or FM, etc., etc., or you could use digital modes like we talked about in the last section. If you look at this diagram that we drew on the screen here, you'll see several different types of radio waves. And a Morse code signal would have a continuous wave that's sort of interrupted in order to make the beeps, which we call the dits and the daws. And that's why it's called CW. It stands for a continuous wave. So for example, this might be one beep here, like beep, and this is an unmodulated RF carrier. It's just a continuous wave which makes a beep noise. Other waves don't quite use a continuous wave like this. For example, SSB is another common voice mode. It uses amplitude modulation, which you can see over here. And amplitude modulation is interesting because it uses the height of the radio wave to send the signals. The height of the radio wave changes in order to convey the information of your voice and your sound. FM, another popular voice mode, uses frequency modulation. That's why it's called FM. And FM works by changing the frequency of the waves in order to send the audio. Whereas AM changes the height of these peaks, FM changes the width between them. And if you notice closely, this actually ends up changing the frequency. So it modulates the frequency in order to convey information about the sound of your voice. So anyway, the point of all this is that a multi-mode radio is just a radio that can do all these multiple different types of modes, such as CW, AM, FM modes, and digital modes. Now, I want to make a quick note here. When you're taking the ham radio exam, the test writers tend to get a little technical. So instead of saying the word radio, what they're going to say a lot is the use of the word transceiver. They're going to use that word. And so what is a transceiver? Well, I'm going to talk about that. A transceiver is a combination of a transmitter and a receiver. A transmitter plus a receiver is a transceiver. Believe it or not, back in the old days of ham radio, the transmitter and the receiver were separate entities, and you had to buy both of them, and there were two big chunks of equipment sitting on your desk. Now they're combined into just one unit, and that's how we get the word transceiver. It's a combination of the words transmitter and receiver, transceiver. Basically, it's just saying a radio that transmits and receives. That's what a transceiver means. So now let's take a look at some of these multiple modes in depth. And let's start off with single sideband, which is an AM mode. So single sideband is great for weak signal work because SSB signals have a very narrow bandwidth. And we're going to talk a little more about bandwidth more at the end of this lesson. But basically it means that SSB doesn't take up a lot of space on the ham radio bands. The signal isn't that big. The FM mode, on the other hand, is great in terms of audio quality, but only when you have a lot of space on the bands. It takes up a very large amount of bandwidth, which is one of the reasons why it sounds so great, because it can transmit much more information about the audio. But when space is more limited, you'll definitely want to go with SSB, which takes up considerably less space or bandwidth on the bands. And SSB is also great for weak signal work because it's more efficient. Because since SSB is so tiny, you're concentrating all of this power only into this thin signal. And as a result, that one thin signal is really powerful. Whereas with FM, the bandwidth is much larger, so you have the same amount of power, but you have to use it to power this whole big bandwidth of data, and the power gets spread out more, and the end result is the signal doesn't end up being as strong. So for weak signal work, SSB is better because it has this narrower bandwidth. That means that it's more efficient. The Gordon-West manual also makes an interesting side note here. Most handheld radios don't have SSB capability. They're usually only FM. But some multi-mode mobile stations, like maybe when you would put in your car, they do include SSB operation. Just a little fun fact. That's not going to be on your test, but just something that's nice to know. All right, so again, SSB is a form of amplitude modulation, AM. So just think of your voice moving up and down as you talk. That's amplitude modulation. And SSB is a form of that. That could be on your exam, I believe. When it comes to SSB on VHF, UHF, and 10 meters, another thing the test will expect you to know is we always use the upper sideband. we don't use the lower sideband, we use the upper sideband. You see, single sideband means we're using one sideband, and I'm not going to go too in depth into what a sideband is and how all that works because it gets a little technical, but just remember that these, on VHF, UHF, and 10 meters, we always use the upper sideband, and even if you don't know exactly what that means, you can still remember it. And if you have questions, you can look in the Gordon West manual, or you can ask a question on the forum in this course, and I'll try to get back to you. So when we're using these modes AM and FM, and we're transmitting our voice, and we're combining our voice with a radio frequency signal with an RF carrier signal, what they call it, that's called modulation. So for example, with amplitude modulation, we transmit the sound of my voice by moving the radio signal up and down. My voice is modulating the radio signal up and down like that. With FM, my voice is modulating the radio signal to change frequency, and we're modulating the radio signal, and that's how we carry information about the voice. So that term modulation is something you definitely want to remember. Now, SSB voice, or AM SSB, is permitted in at least some portion of all the amateur bands above 50 megahertz. So VHF and UHF, you're going to have access to that. Whatever ham radio band it is, as long as it's above 50 megahertz, which is 6 meters, there will always be some portion of the band that allows SSB operation. And as a technician class operator, you will be able to use SSB operation. So again, SSB is a form of AM. I forgot to point that out earlier, but you can see it on the board. All right. Now, one interesting thing about SSB is many times you might be tuning around on the SSB bands, and you might receive a voice that sounds really too high or too low pitched. You might come across like Elmo or something, or someone who sounds like Elmo from Sesame Street, talking with a really high pitched voice or a really low pitched voice. It sounds almost unnatural. This is a quirk with USB. It usually means that you're slightly off frequency. With SSB, you have to be right on frequency. If you're a little bit off, then the voice starts to sound, the pitch gets all messed up unless you're right on the exact frequency. And to fix this, if you're hearing Elmo or if you're hearing someone with a really deep voice, on the other hand, one thing you can do is you can use the RIT knob. And the RIT knob, that stands for Receiver Incremental Tuning. And basically what it does is it's used to make small adjustments to the receive frequency on your radio. So it can be used to remedy this problem because you can change the receive frequency, fix that problem with pitch. Of course, you could also just turn the big tuning knob on your radio to adjust the frequency. You may not even need this. And again, this stands for Receiver Incremental Tuning. You incrementally tune the receiver of your radio while leaving the transmit alone. It makes slight adjustments to your receive frequency, which can be useful in certain instances. And it's also useful in working satellites. Sometimes you have to receive on a different frequency than you transmit on. One thing to note here, though, RIT changes your receive frequency, but it does nothing to change the transmit frequency. So if you change the receive frequency with RIT, the transmit frequency stays the same. And all of a sudden, now you're receiving on one frequency and transmitting on another one. And normally, you really wouldn't want to do that. Ordinarily, when you change your receive frequency, you also want to change your transmit frequency to match it. So it's best to just have RIT off most of the time. I just use the big, giant tuning knob on the radio to change everything at once, which is probably what most people normally do. All right, anyway, moving away from RIT, now what I want to talk to you about is an oscillator, and this could be on your ham radio exam. And the name of a circuit that generates a signal of a desired frequency is an oscillator. An oscillator generates a signal of a frequency that you want it to. So remember, the frequency of a radio signal is determined by how quickly it oscillates up and down, up and down. We talked about that in an earlier lesson. I forget which number it was, but it was pretty early on in the course. And anyway, it oscillates up and down. That's the frequency. So it makes sense that an oscillator is responsible for generating a signal with a certain frequency. Those words frequency and oscillate are related to each other. All right, and the last thing we're going to look at in this video lecture is the concept of bandwidth. And we touched about this a bit in the beginning of the lecture, but I want to go more in depth here. And we'll also continue it with it in the next lecture since I'm splitting this lecture in half. All right, so bandwidth is essentially how much space a radio signal takes up on the airwaves. So for example, you pretend this is 28 megahertz over here. This is 29 megahertz over here, okay? And in between are all the other frequencies. And this isn't to scale, but it's just to give you an illustration. Bandwidth is how much space a radio signal takes up on the airwaves. And the amount of bandwidth a signal uses depends on how much information it needs to carry. For example, a slow scan TV signal, which transmits video and voice at the same time, kind of like Skype, I guess, it takes up a lot of bandwidth because it's transmitting images. So it takes up a lot of space on these bands. FM voice and SSB voice, they take up a little less bandwidth because they only need to transmit sound. There's less information. CW or Morse code takes up the least amount of bandwidth because it only needs to transmit little beeps, and that really doesn't require much information at all. Again, it's just a continuous wave. In terms of SSB, the exact bandwidth on a properly adjusted SSB transmitter, your voice is going to take up somewhere around 2 to 3 kilohertz of space on the band. So say it might take up from, it'll take up 2 to 3 kilohertz of space on the ham radio airwaves. That's the bandwidth. So an appropriate receive filter bandwidth, because your ham radio also has bandwidth, not only when you transmit, but it also applies to when you receive. You can filter it so that it only receives a certain bandwidth, only a certain section of the ham radio airwaves. It only receives a certain amount of space on the bands. An appropriate receive filter bandwidth to select in order to minimize noise and interference for SSB reception is something around 2400 hertz, which is a number you might need to know for the exam. An SSB signal takes up about 2,000 to 3,000 hertz of bandwidth, and 2,400 hertz is right in the middle of that range. So if you have a 3,000 hertz signal that's being transmitted on the airwaves, your radio is receiving 2,400 hertz of that. It's going to be right in the middle of that range. Your radio will receive the SSB signal. It'll block out everything else, and that's why we have bandwidth for receivers. The receiver only receives this much of the airwaves, or this much, and it blocks out everything else, which helps us eliminate interference while receiving the signal we want. All right, so that's all for this lecture. We're going to explore this more in the next lecture. I'm splitting this lesson in half because it's kind of long, so I'm going to stop here, and I'll see you in the next video.